In this video, I'll be demonstrating a basic program in Python created by my partner Hakeem and I. Our idea was to write a log analyzer that detects unusual activities, like when a user suddenly logs in from a different geographic location or tries to log in with a different password multiple times in a row. First, we created 5 text files with sample data. This sample data consisting of log strings that follow a general format that includes a timestamp, the user's name, whether it was a failed or successful login, a made-up IP address, and a location. We stored all these logs in a dictionary and named it log data, and we named each of the 5 text files according to the weekday the logs were made on, so from Monday to Friday. Also worth noting is that the log strings in these text files are raw log strings that will have to be converted into parsed log strings later on so that our program is able to run properly. To shake things up, we had each text file contain a different amount of total log strings, and we also made each text file contain different types and amounts of login errors or anomalies. To keep track of the different amount of log strings in each text file, we set a loop that prints the name of each text file and the number of log strings each file contains. Having all the files and the logs they contain laid out at the start of the program gives the user more context when going into using it. Otherwise, our program would just throw the user right into the command line interface with absolutely zero context about the log files they're supposed to analyze. Shortly after, we established the main function and we assigned a variable to each text file. After that, we created another dictionary with key-value pairs to further establish each weekday with their corresponding file names. The keys in the dictionary are the string literals Monday, Tuesday, Wednesday, Thursday, and Friday, and the values are the actual file names of the log files created earlier in the program. Establishing this dictionary serves a crucial role towards the usability of our program because later on when the CLI has the user enter which day of the week they want to analyze logs for, the user will only have to type in Monday or Tuesday and so on, rather than the more technical file name. After that, we dedicated the next lines of code towards error handling. Here we guarantee that there are no missing records, or files in this case. And we did this by creating another for loop that iterates through the file names stored in the log files dictionary. First, it tries to open a file in the read mode, and if the file is there, then the program passes and moves on to the next file in the loop. However, if any file doesn't already exist, then the function raises the file not found error exception and opens the file again, but this time it's opened in the writing mode, thus creating a new empty file. And of course, all this error handling is done so that the program doesn't experience a runtime failure later on. Then we get to the command line interface. First, we created an outer while loop and established the selected file variable as an empty string. Then we created the inner loop where the user's options are printed out, and the input function asks the user to type out which day of the week they want to analyze logs for. We also used the .lower string method so that whatever the user types in is converted to lowercase. This ensures that the input is case insensitive, so the user can type in Monday with a capital M or a lowercase m and so on. Together, the outer loop and inner loop make up a nested loop within the CLI, where the outer loop manages the entire analysis session and stops only when the user chooses not to analyze another file by typing in no. And the inner loop manages input that is typed in by the user, like whether they choose Monday, Tuesday, or Wednesday, and we used an else statement to account for whenever the user typed in an invalid entry. Whatever file the user selected is then read in its raw log form. And from there, the process of parsing the raw logs into a more structured format begins. First, we created an empty list for the parsed logs, and then we used a for loop to iterate over every raw string stored in the raw logs list. In this loop, the program calls the parse function, and what this function does is split the log strings according to where the commas in the log strings are located. So then the log strings are nicely separated into different parts like the timestamps, the IP addresses, and the locations, and anything other than these specific parts are stripped from the files. Once the parsing is done, the parsed entries are appended to the parsed logs list. The parsed logs are then analyzed for failed logins and geographic shifts using the helper functions, and whatever anomalies are found are assigned to the failed logins and geographic shift variables. Then we combined the anomalies under one variable, and we called another helper function to report all of the anomalies. This helper function prints out a nice looking security report with a header and a footer, and it also has its own logic behind it that uses an if statement to check the contents of the anomalies list. Then we used the save results helper function to iterate through the parsed logs and convert them back into their original comma-separated string format, and then it opens the original log file in write mode. The write mode guarantees that the file contents are overwritten with new log strings, and even though the program's anomaly detection doesn't modify the log content itself, this helper function is still important because it reads the file and cleans up all the spacing and formatting inconsistencies, and then it saves that corrected version back into the file. Then we ask the user if they want to analyze another file using a Boolean expression where if the user types no, the program ends, but if they type yes, then the outer loop runs again. The next lines of code show the logic behind each of the functions that were used above. So if you recall the read logs from file function, this function was meant to open and read the specified log file. It iterates over the file lines and uses the strip method to remove any trailing new line characters before appending the raw log string to a list. The parse log entry function, as you can see, strips the log strings based on the placement of the commas and recognizes the different parts of each log string, making sure there are no less than 5 different parts in each log using the len function and a comparison operator. And the 5 different parts it's looking for are shown in the log dictionary. And then a quick warning is printed out if the log has less than 5 different parts. The logic for the analyze failed logins function starts with an empty list for failed attempts, then creates an empty dictionary that tracks failures per user, and establishes a threshold of 3 failed login attempts. A nested for loop is used to eventually print an anomaly message once the threshold is reached, and the list of strings where the failed login attempts happened are returned. The function that analyzes geographic shifts also creates an empty list and dictionary. It identifies the users are the keys in the dictionary, and for each user, the logs are sorted chronologically based on their timestamp. The use of the lambda function was suggested by AI, and it's commonly used in cases where particular syntax is used, like our timestamp, which follows a year, month, date, and hour, minute, second format. The rest of this function was also suggested by AI to accommodate the fact that we wanted to keep our program simple by not importing anything from external Python libraries. So the function's logic remained fairly simple, as you can see. If the previous IP and the current IP don't match, then the geographic shifts are recorded and the list of strings are returned. The combine anomalies function uses the list concatenation operator to join the filled logins list and the geographic shifts list into a single unified list. The report anomalies function, as stated earlier, prints a header and footer and uses a conditional check to determine if any findings were returned. If the list is empty, it prints no anomalies detected. Otherwise, it iterates over the list, printing each anomaly message. And the save results function opens the file again in write mode and writes the different parts of the file back into the original log string format. Again, even though the log content itself isn't visibly changed by the anomaly detection, we still need to convert the dictionary back to string format for saving. This prevents the recurrence of formatting errors in the log file and eliminates the chance of minor flaws interfering with the program's parsing or analysis during later executions. Finally, we need to call the main function, and then we can run the program. When we analyze logs for Tuesday, we get 3 geographic shifts. For Wednesday, we just have 1 failed login anomaly for Preston. We don't have anything happen on Thursday. For Friday, we have geographic shifts and a failed login. Now, if we try this for Saturday, we're told that's an invalid entry, and we're prompted to try again. So if we enter a weekday like Monday, it should work. Yep. To end the program, we simply enter no. And that concludes the walkthrough video of our log analyzer program.